installing like a new antenna in my apartment. I want it to work. All right, there we go. So this should be doing good. Says both qualities are excellent. You're on wireless. I'm on. It's on a cell signal. Is what it is. So yeah, my cable, bro. The upload's garbage. And I was paying like $90 a month for Spectrum. It's the only option I have. This is the terrible thing about like some apartment complexes in LA is that like you don't get much like options in like who your service provider is. So no Google Fiber. Yeah. No, none of that, dude. Nope. No. Dude, I would, dude. If I could pay for Google Fiber, I would do it in a fucking heartbeat. But it's not available. And like they're not going to install it in my complex anytime soon. So my only option was to go with T-Mobile for their home internet, which is pretty quick. It is very fast. The issue is that like my upload was getting kind of crunched in the middle of the afternoon. I think because too many people are like using the signals. So I bought like a fancy antenna situation that I hooked up. I'll show you guys. Where is it? There we go. So this is me like taking a ladder and installing a whatever, like a dish. This thing cost me like $400. But it did double or at least triple my upload speeds I was seeing over the weekend. We're going to see if it holds this way. Porter, no one cares? What's up, Porter? Be nice, dog. There's no need to be mean. Alright, let me see if I can stream on Discord too. We're going to test everything today. Looks good so far, right? Yeah, I'm happy. I'm happy so far. It's not too bad. I was getting better speeds at least, so, you know. I think it was working. Because, what was it? These were my speeds before. So my download's great, dude. I get 500 down. It's super great. I'm really happy about the download. It's this upload speed that I need. I need that upload speed to get better. It's so bad how asymmetric every internet line is. But anyways, this is what I got recently with the upgraded panel I put in. 700 down, 26 up. So I was getting like double up, which is great. I think I need at least like 20 MIPS to stream to TikTok. I'm not even doing TikTok at this point. Just to get like Twitch and YouTube to play nice with each other. I need at least like 20 or 30 MIPS. No, that one cares. Yes, no, that one cares. Sorry, what was I had something from Sib. Sib said something in one of my chats. Sorry, I gotta go find what chat that was in. Sib, where'd you say something? What chat you talking? Mr. Lawn, you had a good question about the thing. We'll do that. Sib said, "Hi, Professor. I was wondering, you did say that the extra practice questions from each chapter is also a good indicator for test questions." Yes. Well, I see you're on YouTube. It's like, which YouTube are you on, though? See, because we do it on two. I do it on both. Like, if you look, this is why I wanted to get a better internet connection, because I'll show you real quick. Because we have both a vertical that tends to get like more mobile people, and then I have the horizontal that I run for if you're watching on a desktop. Yeah, because horizontal is like a little bit easier to see things. So I'm running 2 YouTube streams, plus a Twitch stream, plus a Discord stream right now. What's up, Winnie? Winnie, I saw you get some really good physics questions. I'm happy to help you with those, Winnie. I appreciate that 5K is trying to help you out as well. But feel free to, if you need help with physics, I'll go over them on the stream today. You need help with that question? Okay, we'll go over it. Okay. Quick announcements before I start. Where did I put it? It's in my Discord somewhere. One sec. Where are my Discord announcements? There we go. So, Discord announcements. Oh, summer camp starts today. Yes. So, if you're a student and you want to win some prizes and like learn some shit over the summer, join summer camp. It starts officially today. We had our pre-registration for the last 2 weeks. It's free. And basically it's a cool little thing we run for students to like play video games with each other. We also have chess tournaments. We have a talent show at the end of the summer, which is really funny. And we're also going to do like some math challenge stuff, but you can get points, and then with the points I'm going to give out a Nintendo Switch 2 to someone who wins. We'll do for like the 2 weeks leading up to like the official start, I let people earn points through like, it's called like a daily command, where like if you just go into Discord and hit daily like every day, it rewards you with points. It's a way for you to like stay in touch with like what's going on. But we're resetting all that today. I will do a giveaway maybe midway through the stream here for those that already were getting points during the pre-registration period, just to show you how it works. So yeah, I'll explain more about that later. Let me do some physics questions first for people. And then also, yeah, we have a new server tag. So I don't know if you notice, if you want to rep our server, be cool. We have, I asked a bunch of my mods what letters they wanted, and they said they wanted gold. So I was like, cool. So there you go. You get a sweet, it's free. Well, it's not free to me, but it's free for you. We luckily have some awesome server boosters, but yeah, you can put that tag next to you on Discord if you want. Just, you know, if you want to rep the gold, we have it for you guys. Quick Sarion says, how do I learn math here? Just watch, bro. Or you can ask questions. Like, do you see how Winnie asked a question here? That's a great example of a question that like I can teach from it. So that's one way to learn. You can also ask questions yourself, or you can, yeah, just watch everyone else. Watch when I answer other people's questions. Okay. Yeah. And if you're curious about anything else going on in the Discord, please DM me. I'm around. I'll be making announcements. Okay, cool. Let me see. We got some good help screenshots. That's from Mistral. Yeah, Mistral, let me help you with that one first. Let me do Mistral's question first. I saw you submitted that at like midnight last night. But all good. All right, let's start the stream off. Welcome everyone to Office Hours. My name is Dr. Gold. It's Actual Education. The stream that helps you out with math homework, science homework, all sorts of fun stuff. Let me do Mistral's real quick. This was a good question. What course should you do? Whichever one you want, man. I mean, I think calculus is a great course, honestly, just to learn stuff. Okay, Mistral. So, says, student holds an 80 centimeter lab pole 1/4 of the length from the end of the pole. The pole's made of aluminum. The student strikes the lab pole with a hammer. The pole resonates with the lowest possible frequency. What is the frequency? Okay, so let's do that real quick. So, if you have... let me get a... Yeah. If you have a pole, for instance, here, okay, and you're choosing to fix it, right, at, we say, like a 1/4 of a wavelength. The material does matter, yeah, because the speed of sound is different in different materials, yeah. So if this, let's say we're fixing it, I don't know, that's kind of like a 1/4, right? Yeah, it's fixed, okay. That means it can't oscillate right here. This would be called a node. Right? Yeah, Winnie, I'll go over yours. Let me explain this one to Mr. real quick, and then I'll do your question. So this is fixed, and then since these are not restricted in terms of like boundary conditions, right? These are going to be, this is kind of like open. And if something is open, that's the same thing as like an antinode. So, you know, let's remember, let's see, node, antinode, standing wave. Yeah, you can have stuff like this, right? So, for instance, if you had like a closed situation, which is where the boundary conditions are fixed on either side. Well, this is closed. This is open closed. We're just like closed dog. Or like, yeah. Okay, I guess this is like closed. Yeah, here we go. This is closed. So these are the different wave patterns, standing wave patterns for something that is closed. And then here are the standing wave patterns for something that's open, closed. And then also open, open. Yeah, kind of cool. Yeah. Okay. So we have a situation. Exactly. Yeah, it's exactly. Yeah, it's not a hollow rod sib. So it's kind of moving. Yeah, it's like a guitar string is kind of what I would think about it. So this is all. I think technically these are longitudinal modes is what they talk about, but that gets confusing to think about because then you got to be thinking like this. But maybe think about it just as a string, right? It's fixed here, but it can move up and down here, and it can also move up and down here. So at both ends, you have it open, and you have it fixed at a quarter of the length. Yeah. This is equal to 1/4 L. Okay. So if we have something open on both sides, right? Okay. Then these are the different patterns you can have, the harmonics, as you like go higher and higher in terms of frequency. And I need the case where it's closed at a quarter of the length of the thing. Well, that occurs here. Do you see how if I were to break this into like quarters, right? That you would have a node at 1/4 lambda, or 1/4 of the length, and then another one at 3/4 of the length. That's a way, right, for you to have a standing pattern that works like this. You could have also had it like this, right? This would also work as well. But the question asked the lowest possible frequency. And let's remember, right, that for the speed of a wave, this is equal to f lambda. So if you want the lowest frequency, you want the highest wavelength. Okay. So I'm trying to find something that has the highest wavelength. Let's just 1 second. I gotta restart this. Been teaching for too long today. Okay. So Mistral says, can you explain the wavelength being after 2 antinodes, not just 1? 2 antinodes. Oh, yeah, okay. Well, so for a wave, right? A wavelength. It's not really 2 antinodes. It's like 2 peaks is what it is, right? So let's say we have a wave that looks like this, yeah? The distance from here to here, that's equal to 1 wavelength. Also the same thing from like here to here. This is also equal to 1 wavelength. It's like same position, but also like same trajectory. So here, both of them are at, what would we say? They're both at like zero amplitude. Right, if this was my thing. They're both at 0 amplitude. But this is like going down, also going down. So this is like not a wavelength. It's from here to here. So this is an antinode, peak to a peak. That's a wavelength. Also, if you did this, that's also equal to 1 wavelength. So this is equal to 1 wavelength. Okay? Just different ways you can measure a wavelength. So, the condition, right, for having a node at a quarter the length of the pipe has a couple cases. So you can have the case where like 1 full wave, right? You see peak to peak fits in here. So in this case, you would say, oh, well, L is equal to 1 lambda. Or you could have had this case, which is, so those two are only half a wavelength apart. Which two? Here to here is only half a wavelength apart. Agreed. Yeah. But this is the full wavelength. Yes, the 1/4 and 3/4. Exactly, Mistral. Yeah. That's half a wavelength. Yeah. Because here it's like it's at 0 but going down. Here it's at 0 and it's going up. It needs to be going in the same direction as well for it to be considered a wavelength. So here you have the length is a full lambda. Here you have, right, the length is like 1.5 lambdas. Right, so here you can say, oh, well, here like L equals 3/2 of a lambda. And so if you're measuring what lambda is, okay, well, in this case, lambda just equals L. And here, you have lambda is equal to 2/3 L. But let's remember, if I want the lowest frequency, I want the highest lambda. What's up, Bergie? So the highest lambda is this case, right, where it's a full L. And so in this case, I say, all right, cool. Well, V is equal to F, and now lambda is the full length of the pipe, and that's 0.8 meters. And then you have to look up V, which is the speed of sound in steel. That ends up being 5,200 meters per second. So this equals F times 0.8. Divide both sides by 0.8. And then you get F, which I think is equal to 6.4K. So here we go, 5,200 divided by 0.8. And yeah, 6,500, whatever, it's about the same. Yeah. 6.4 kilohertz. So that's why this is the correct answer. Does that make sense there, Mr. Ron? Yeah? I will give it to you. On a test, I'll give it to you. I'm not going to make you search shit up. That's, like, dumb. On a test, yeah, I'll give you what the speed's supposed to be. That's a homework question. They make you, like, look things up. Okay, Winnie, here. I'll help you out, Winnie, with yours. It looks like you drew, like, a lot of stuff. I'm confused what you're drawing here. Let me know, Winnie, if you're ready. I'll go through this one with you. Okay. So let me see. Velocity only reaches 4 meters per second at t equals 3. Okay. All right, let's see. Okay. Let me just read the question first. So it says okay, this is a velocity versus time graph. It's always very important here, Winnie, to know what graph you're looking at and then what the different things represent, okay? So for V versus T, that means the slope is equal to acceleration. And then the area, like the area underneath the curve, is equal to, we say the displacement. Or, yeah, displacement, sure. I forget it's like distance or displacement. I think it's displacement. Or I could also say like, yeah, whatever, change in position. Okay, so always like kind of write this down once you know this. Because that'll help you figure out what you got to look at on the graph. Right, if it was acceleration versus time, then you don't really know what the slope is called jerk, but like you don't really need to deal with that. And then the area would be the change in velocity. And if it was position versus time, now the slope is velocity and the area is just like whatever. Okay. One can conclude that the average velocity during the 12-second interval is 24/7. Oh, okay. Average velocity. So if you want to figure out average velocity, so average velocity is equal to distance over time. Or, sorry, displacement over time. Okay, so for the full 12 seconds, Winnie, if I want the displacement, let's remember that displacement is the area. Okay, so I need the area of this thing. So, here, let me move this over somewhere else. We'll deal with that later. I think it's something you wrote. I'll just show you how to do all these parts, and then that'll teach you some more stuff. Okay. So this is the area of B versus T over the time, which in that case is 12 seconds. It's a zapatroid. What's a zapatroid? It's a trapezoid, no? Is this not a trapezoid? I'm pretty sure it's a trapezoid. Or it's a... Yeah, isn't this trapezoid? Oh, you're being silly. Okay. Trapezium. Trapezium, I think, is when it's like 3D or something. Or whatever. Okay. Okay, so this is a height of 4. So this has a distance of 5. So this area here is equal to 20. Right? Because you got 5 here. You got 4 up. That's a square. That's an area of 20. And then this and this combine to make another square, basically. Or a rectangle. Sorry, it's not a... Sorry, trapezium is a muscle group. Okay, that's true too. Okay, and then this is a 3 by 4. So that's going to be 12. Okay, which really means this is 6 and this is 6, right? Because if you do base times height and then 1/2 that. So, can we do problem 6 on the sound and music homework? Yeah, sure. I think Sib has a question I'm going to do next, and then, yeah, I can do that one, Catberry, for sure. So here, the area is 20 plus 6 plus 6. So that's going to be 32. Over 12, which is not 24 over 7. Right? So that's why this one's wrong. No. Its velocity for the first 3 seconds is uniform and equal to 4. That's also wrong. So for the first 3 seconds, the velocity is changing. It goes from 0 up to 4. So this is also wrong. The body has constant acceleration between 3 and 8. It's kind of funny. 13 love kids. Follow our school back. Love the content. That's cool. What's your school? Do you have a school Twitch? Love kids? Is that what you're saying? Yeah, okay. So constant acceleration. So let's remember acceleration is the slope, right? So between 3 and 8 seconds, is the slope constant? I mean, it is. It's a constant of 0. So, yeah, this is technically correct. Right? Oh, explain what 555 meant by for this. All velocities between 0 and 4 happen between 0 and 3. Oh, yeah, that's just, I don't know, that might be like some ChatGPT, honestly, Winnie. But what that statement is saying is that if the velocity was always equal to 4 milliseconds, then here it should be equal to 4, but it's not. They're saying that the only time between 0 and 3 seconds that the velocity is equal to 4 is at 3. Right? Because here the velocity is 4 meters per second. Yeah, not it's ms to the -1. That's meters per second. Yeah, that's a really long, drawn-out way, Winnie, of just saying that, like, the velocity is only 4 here, because here it's, like, 3, here it's, like, 2, here it's, like, 1. That's all they're really saying. The body has uniform retardation from 8 to 12. Again, why the word retardation, dude? What? They should say deceleration. Retardation? Really? Is that a word? I mean, technically, yes. Okay, if this is, like, deceleration, then this would be correct. I'm assuming retardation means, like, negative acceleration, which, yes, acceleration, remember, is the slope of this. So, yeah, the slope is constant, right? It is a constant negative number. So, I mean, this is technically correct. But also 3 is also correct, because it does have constant acceleration. It has an acceleration of 0, though. That's where I start to be, like, a little confused here. Usually we say like constant non-zero acceleration, right? I mean, if something has 0 acceleration, does it have constant acceleration? Like, is 0 an acceleration? I feel like it doesn't. I feel like the only correct answer is 4 then. Do you know if the correct answer is 3 or 4, Winnie? I'm pretty sure it's 4. Yeah. It's 3 and 4? Okay, then sure. Okay. Then that makes sense. I mean, it's a constant 0. Oh, it's just 4. Okay, good. Then yeah. Yeah, so for 3 here, the acceleration's equal to 0. And that's... you don't have acceleration if acceleration is 0. Yeah, Jeff says, uniform retardation, also known as deceleration, refers to a situation where the velocity of an object decreases by the same amount. Yes. What's up, Chance? 3 was our friends group doubt. Yeah, I can see why you would choose 3, to be honest. Because the acceleration is constant, but it's not non-zero is the issue. And because it's 0, so I don't think there is acceleration. Does that make sense, Winnie? Nice. Good. Well, I'm glad you got it. Awesome. That's great. You get a point for asking a question, Winnie, you know? I'm glad you're taking, like, physics over the summer. Yeah, please ask more questions. Like, we'll definitely help you out. Yes, sir. Okay, cool. All right, let me see. I got another question from my physics office hours. Sib has one. Oh, and there's something with a figure and a thing. And then I see the other questions. Equity, Chantrix, I see all yours. And 555, I'll do yours. How much of time I'll spend on learning school math? I know nothing. I think you're going to spend a lot of time learning math, dude. So, what's up, Equity? So yeah, you might as well do it, I mean, now. Just chill out and just learn some math. I mean, we're doing a lot of physics right now, but I will be doing some math later in the stream. And then you will know not nothing. You will know non-nothing. And you will prevent retardation, apparently. That's too funny. They use it. What? Okay. Let me see, Sib. All right. In the figure, a sound wave starting from a speaker on the left of wavelength 1.2 divides into 2 equal parts that recombine to interfere constructively at the receiver on the right, with the original difference between their paths being R2 minus R1. This was actually an A-levels question on a UK exam. I remember this question coming up. I've done this with noise before. That's too funny. Rank the following situations given according to the intensity of the sound receiver from highest to lowest. Assume the 2 balls absorb no entry. These are from the US, but I've seen this question on the UK like A-levels exam. You're okay, Bergie. Okay. So the wavelength is... So here's the cool thing. So if you, for instance, shift this up by, let's say, like, X meters, okay? You increase the path length by 2x meters, okay? So I say for every X you slide up, the path length goes up by 2x. The reason being is now you're making more distance to travel here and more distance to travel here. Okay. So if you wanted to have positive interference, like you want them to line up on top of each other, you need R2 minus R1, so the difference in the path lengths, to be equal to 2n lambda, right? So let's pretend like you have the blue one. Let's say you got a wave like this. And then let's say you have the green one, which looks like this. These are two paths, and yeah, so what's happening here is this is like a pipe within a pipe, Sib. So you can take this part and you can like slide it up. Nice. You can like slide it so that there's more length. Think of it as like it's kind of like a trombone, maybe. Trombone's a great example of this. Thanks for the follow, dude. Good trombone animation. Yeah. Like, when you move a trombone, like, in and out and stuff, you're increasing, like, the length of the pipe that the thing has to go through. So, in this case, if you take this whole section here, and let's say you start, like, pulling it up, do you see how the thing has to travel an additional distance? Abo says, can you explain the concept of a scanning monochromator system? Maybe later. I'm answering some direct physics questions now for my class, but if I have time later, yeah, I can go into it. I'm nice, thank you, man. Okay, does this make sense, Sib? So as like, let's say for instance, I pull this out an amount X, okay? Now the total path that my sound has to take on this top portion is going to be an additional 2x, right? Because it has to go an additional x this way and an additional x back this way. So it increases the distance it has to travel by 2x. The reason why this is important is that, let's say, for instance, the green path has to go further, okay? You could think about like, oh, well, now the wave is like starting further back. Or you could think about like it's finishing further, I guess. Yes, that's why the path difference gets different. Exactly. So if, for instance, if your path difference varies by half a wavelength, right? So if this green thing suddenly has to travel half a wavelength more, now you start getting destructive interference, right? At wherever they meet. But if you have it, for instance, go a wavelength and now, sorry, if you have it go a full wavelength, now, sorry, full wavelength means there's constructive interference. Okay, so sorry, this is not 2n lambda. Sorry, this is n lambda. I'm being dumb. Sorry. The 2 comes in to the fact that, like, you only have to move it, like, half the distance. Okay, here we go. This is what I want. This is constructive. And then... yeah, not really pi, though. Yeah, you don't want to do it as pi, because there's no pi here. Because now we're talking about lambdas. We're talking about, like, space instead of, like, angle. Yeah. Well, so any multiple of lambda will give you constructive interference. Okay? If you have R2 minus R1 and it's equal to 2n plus 1 over 2 lambda, this is destructive. And that's because this will pick out like 1/2, 3/2, 5/2, and so forth, lambda. So yeah, if green, remember that this is a full lambda, right, from here to here. This is 1 lambda. So if I move it half a lambda, you see how like this thing moved from here to here, half a lambda? Now you get destructive. If I move it a full lambda, we're okay. If I move it 3/2 of a lambda, right? Because now this is like another half a lambda. Now we get destructive. Okay? So it's not pi per se. It's lambdas. So if the path difference varies by any like multiple of lambdas, you're okay. You get constructive interference. It's when you have like the odd half multiples that you get destructive. But here's the interesting thing, is that this path difference is equal to 2x, which x is the amount that you slide it, right? Because if I slide it an amount x, the path difference changes by 2x. So this is equal to 2x. So then you can like kind of see some cool stuff here. Okay. So 0.2, 0.2, 0.2. So it's going to be its least, right? So here, let's put it in terms of x, because x is how much you're moving it, right? So if x is equal to n lambda over 2, you get constructive. And if x is equal to 2n plus 1 over 4 lambda, you get destructive. And let's remember that our original lambda, right, is 1.2 meters. So in this case, if x is equal to n times 0.6, you get constructive. And if x is equal to 2n plus 1 over 4. So actually, let's do this. Let's do the 2n plus 1. Because I know this is just odd numbers. N can be whatever. Just has to be an integer. Times 0.3. This is destructive. Okay. So the first destructive is when you're at 0.3 meters that it's moved. Okay. So from its original position, the sliding section is moved forward by 0.2. This is getting towards destructive, right? And then it slides an additional 0.2, so that's 0.4. So this is really weird, actually. So here, let's make like a little graph. So I know it's destructive at 0.3, and then it's constructive at 0.6, right? And then it's going to be destructive again. So here, this is positive. This is like 0. Or let's just say this is destructive. And then this is destructive again, because this is 0.9. And then this is constructive again at 1.2. So we end up moving it 0.2 and then another 0.2. So 0.2 is here, right? This is A. We're at 0.2. Then we move another 0.2. So then this is B, which is like 0.4. And then we move it another 0.2, which is C, and that's at 0.6. And then we move it another 0.2 here to like 0.8. Okay, and then that's D. So it's going to have the most intensity here at point C. That's when you have constructive interference. So this is going to be the most. I'm tempted to say for all these other ones, though, for like A, B, and D, I think these are going to be the same. Because do you see how they're all 0.1 away from being like totally destructive? So I think A, B, and D are all the same. What question was this? So these are the same. I think B should be 4.2 and not 4. Wait, what? Oh, 0.4. Yeah, no, I said that. Did I not? I said 0.2 then 0.2, right? 0.2, 0.2. Yeah. Yeah, that's 0.4. Yeah, so I think A, B, and D are all the same. And they're low, and then C is the highest. because you have the minimums at 0.3 and 0.9, and these are like equal on either side of it, you know? It's kind of like having, so this is perfectly destructive interference, but you could have like here or like here. You see, like if you're on either side of it, you're still going to have the same amount of destruction to it. And then this is like perfectly constructive. Question 7. Let me go check that. For Snabbit. Man, what a doozy of a question, though. Wow. Question 7 on sound and music. Yeah. Yeah, and that's the correct answer. Yeah. C is the most, and then A, B, and D are less, but they're all equal. Yeah. Wow, that's kind of a... That's a pain in the ass. Does it make sense, Sib, at least? Yeah. Where that came from? You had to recognize that moving at X caused twice the difference in the path length, and that if the path length is an integer multiple of lambda, it's constructive, and if it's a odd half multiple of lambda, it's destructive. Got it? Thank you. Awesome. Yay. Nice. Love that. Job. Claps.
Well done. Well done.
Okay, sorry, let me see. Someone else in my class asked a question. Catberry, question 6. Yes, Catberry, we can do that. And then let me do the giveaway for the kids that have been waiting around. We're gonna do the giveaway, and then I'll help out some more questions for things. Ooh, sonic booms. Okay. We didn't really go over that much. Well, I didn't have time to really go over sonic booms. That's the issue with this class being like, I get 2 days for a whole chapter. Let's see what we got for sonic booms though. It wasn't Doppler shift. Where was it? Or it kind of was a Doppler shift thing, but it's. Oh, it was in further reading, wasn't it? Oh. What is the velocity of the plane? Assume the speed is found as that. Okay, let's get the speed of the plane first. So, velocity of the plane, just because we're given Mach numbers, right? Ooh, you saw Hidden Figures. Oh, that's fun. All right, let me get a diagram. I need a diagram for this one. There we go. Okay. Let me convert this into a velocity first. So, V source is going to be 1.2 VW. Okay. So that means from this, right? Sine theta. VT over V source. So this is VWT. Over 1.2 VW times T. So that'll give me the angle. And it says after the plane is directly overhead. Oh, okay. So that means 15 seconds. I get it. This is a tricky question. I'm gonna see. I think we have to do like some Pythagorean stuff here. Okay, so you got person here, right? And you have plane, right? And then after 15 seconds is when you hear the sonic boom, right? So then, so this is 15 seconds later. So I think what we can do here... Wait, what are they asking for? What is the altitude of the plane? Uh-huh. So the sound, right, from the sonic boom has to travel this far, right, to get to you? Okay. And you know what this distance is. So this is... I don't know if we need the angle yet. Let me just do it this way. So you have 1.2 VW times 15 seconds. That's this distance, right? And then... Right, okay, opposite over hypotenuse. Okay, so then if I know that angle, that's the same as this angle, which is the same as this angle. VW is the speed of sound, yeah. Yeah, they say the speed of sound is VW. Let me see. That is that. Uh-huh, okay. But then this right here, right? This is just VW times T. So, to get this... I have the adjacent... Oh, wait. Can I just do this? Can I just say VS T squared plus Y squared is equal to VWT? Let me just see if this is the right answer, and then I'll explain it to you. I'm just curious. So I get 1.2 squared T squared plus Y squared is equal to... Or 1.2 VW squared T squared plus Y squared is equal to VW squared T squared. So then Y squared is equal to VW squared T squared. And then it's 1 minus that's going to be a negative answer. I don't want that. wait. Oh, this is not VWT. My bad. One second. This is not VWT. I have not done shockwaves. And we did not cover it in lecture. It's kind of rude they put it on the homework. Okay. Screw this. I don't want this. I don't want this. Okay. Let's solve for theta. And then once I have theta, since I have this, I can then figure out what this is from tangent. Alpha Null says, what's happening? We're getting kind of... I'm getting mind-fucked by sonic booms. Let me make sure I can get the right answer first. Okay. Sine of theta is equal to 1 over 1.2, basically, right? If we take this to be true. VT over VST. Okay. So, for my calculator... arc sine of 1 over 1.2 is that. Okay, cool. 56 degrees. And then I want to know what this distance is. So I know the tangent of theta is equal to my altitude over VST, which is 1.2 VW times 15. Okay, so... if I take the tangent, I'm a physics professor. If I take this times 1.2 times 343 times 15, I get 9.307. Okay, cool. Which I think that's the right answer. I think the answer is 9.307. Let me see. Yeah, 9.31 kilometers. Yeah, so this is equal to... Okay, let's try to explain this. Okay, yeah, that comes from this. Okay, here we go. All right. So, from our diagram, right, of a sonic boom, right? Theta, right here, which is the angle. So, here, this is this our observer? What do we say here? Okay, I think I remember. Okay, yeah. So what they're showing here is you have a source here, original Catberry, right? And that is emitting sound in a circular pattern, right? Well, that's a rectangular or circular pattern, right? And what we're saying is that when the object is here, after a time t, right? That wave pattern will have expanded to this distance. Okay? So after a time t, this v is the speed of sound, VW. I don't know why they're calling it VW, just whatever. They call it VW, but sure. So this right here is equal to VW times t. So we're considering the instance that the plane is exactly right here at the pink. And after a time t, that sound wave has expanded out to here. Okay? Now, as this plane moves to the right, okay? Let's say another amount of time here. Okay? Now, it will emit a wave that after a certain amount of time t will get out to here, right? And then here, after a certain amount of time t, it'll get out to here. And then here, it's only getting to here. Basically, eventually you're getting to a point where you're moving so fast to the right that the waves can't, like, keep up. So, for instance, when you've traveled this distance, which is the velocity of the source, the velocity of u, times t, okay? The wave that you started has traveled out this direction, and then the waves before it, so for instance, this was like when you were a quarter way along your travel, 3/4 of the way, I don't know, like 7/8 of the way, they all form kind of like this wave front, where all these waves are kind of like creating this pressure region right here, because all the waves are smacking the same point. And this is what creates a sonic boom. Is you're creating waves that, because you're so fast, eventually, yeah, it's a conic wave front. Yeah. It creates like a cone of like waves that I guess just like explodes in the air. And what that does is that creates positive interference, right? Because all the waves are ending at the same point. And that creates like a really loud noise, right? That's the sonic boom you hear. Now, if you want to look at the geometry from this, okay? The angle that this wavefront makes with your direction of travel, that's equal to theta here, right? This makes a right angle, right? Whereby the original sound wave you emitted at the beginning will have traveled a distance vt, or v omega t, vwt. So this is the sound, the speed of sound times the amount of time the sound is traveling to get to here. And the amount of distance you as the source has covered, that's equal to vst. So what you have is now a right triangle. Correct. Yeah, it is independent. Yeah. Now, you can see here, Jeff, though, right? If I'm a person here, I'm going to observe a different frequency, right? Because these are all, like, lining up on each other. So, yeah, the speed of the wave does not change unless, for instance, you had wind or something else that's carrying the wave. Yes, because the sound waves are propagating through the medium of the air. Yeah. So anyways, this creates a right triangle where you can figure out what this angle theta is here. Yeah, it's not added to it. It's, in the case of a Doppler shift, it is added to the frequency that you observe, because the waves compress on each other. But they still travel at the same speed. But because they're being emitted like closer and closer to you, that's why they seem to be hitting you at a higher frequency. That's how Doppler shift works. Okay. So this angle theta. Oh yeah, special relativity. That definitely comes up. This is the angle between the wavefront and your propagation, which is also this angle, right? That's the same angle as this. And if we recall, if you have two parallel lines, that these angles are the same, that means that this angle here is also equal to theta. So now imagine you here on the ground, okay? You don't hear the sonic boom, right? Until 15 seconds later, right? Which is this thing has traveled for 15 seconds. So once you get this angle, which is the same as this angle, and you know this distance, which is how far the plane has, or the fighter jet, whatever, has moved in the X direction, you can then use tangent to figure out how high up it is. Yeah, that's different. So that's projectile motion, Jeff. And that's Newtonian. Yeah. Yeah, you think it makes sense now? Yeah, so the sonic boom is not created here, right? Yeah. Okay, cool. I'm not going to do this to you on a test. This is really mean. It's a mean homework question. Yeah. I say rule of thumb is if I can't figure it out like right off the bat, and I've been teaching this for God knows how many years, then like I'm not going to ask you to do it. It's too much. Yes, the sonic boom. Yes, yeah, the sonic boom is the entire diagonal line. Yeah, this is the entire diagonal line. Yes, Aleph Null, you can submit questions to me. There's a website for it if you want. There's the website. Just click on that website. Or put like a www in front of it or something. Yeah, but this entire wave front, because all of these waves are hitting this line at the same point. Which is why you get like massive constructive interference there. You could also think of that like, this is pretty cool here. You could think about the shockwave as being a front, right? And that shockwave was probably generated here actually. And then what happened is that shockwave moved in this direction. Right? And then this is where you hear it. Right? And we just know that 15 seconds later is when we hear it hit here. So the sonic boom actually probably occurred further back. And then the angle just lets me know, okay, well, the distance it travels here versus the distance it travels here in the X and Y direction to then hit me here. Because then this wave front just keeps moving to the right. All right, cool. Thanks. Jeff says, now you have me wondering what sound is. Sound is the compressional movement of like air particles and stuff, yeah. Or any sort of particles. Okay, Winnie, you got a lot of good questions. We got a lot of good questions today. All right, let me go through them. It is pressure moving through the air, correct. Okay. There's a lot of stuff here, Equity. Can you tell me like one part of these you want help with? It does. Or yes. Yeah, if yeah, because it's a compressional wave. Here, let me see if Equity's here. I'm gonna go through the list of like who's here. And then Winnie, I saw you have a lot of good ones too. I like all these questions. Wow, you have like chemistry too. What's going on here? You got chemistry questions as well? What, are you taking all the classes, Winnie, this quarter? What's going on? And Reki's here as well. Okay. Let me do something fun. Because I know you guys have been waiting around. Let me do the giveaway real quick. Let's see. So what did we have for points wise? Real quick, where is summer camp points? Oh, here it is. Okay, cool. Yeah, so if we go to summer camp here and I go to richest, so total amount of points people have earned so far. So equity's got the most. So equity is in first with, here, let's just get all of them. 7540. And then we have Taco with 7493. And then Nick with 7310. And then 555 or 1K with 7093. And then KS2 Neat 14. I think that's Kaz. That's 6811. And then Shantrix with 5654. Oh, Chasm is. Okay, cool. Okay, cool. So then, yeah, here's what it's actually pretty even. But again, this was pre-registration, so there weren't really that many activities going on. The only thing we had was students within the announcement thing could say !daily every day. And if you did it once a day, you got like bonus coins. And this is just really to reward people for like checking into like all the activities we have during summer camp. So it's a way for you guys just to test out how it works. During the actual summer camp, which starts today, we're going to have a lot more challenges like asking questions, chess tournaments, video game tournaments, all sorts of fun stuff. This was just the daily registrations for people. Okay, so that being said, here, let's spin the wheel, see who wins for our little like pre-registration bonus. $10, whatever gift card you want. Ooh, I think by a sliver it's going to go to Equity. Nice, congrats, Equity. Equity, I think you also won the Wibbly thing, dude. You gotta let me know what prizes you want. You have like a backlog of prizes. Congrats, Equity. Okay, cool. Yeah, where's Sir Bob? You won. All right, let's see. How more questions we got? I'm gonna wait for Equity to show up so we can. Then, yes, message me about the Wibbly thing as well. Let me know. I always say, you guys win the prizes, but it's up to you to, like, remind me to give them to you. I'll get you your prizes. All right. Let's see. Chasm, did you have a question about this one? We can do this one for you. Ooh, I will check that one, Winnie, for you. Number 4. All right, here, let's do this one real quick. Yeah, math at last. Okay. Change the slope of the linear function y equals 6x minus 1 so that it will intersect the quadratic function at only one point. The y-intercept value remains the same. Change only the slope. State the equation of the new line. Okay. Okay, so if something's going to hit at only one point, it's got to be tangent to it, right? So, I mean, we could graph this real quick. I think they mean just the first one. And then the points of intersection is where these two hit each other. Interesting. Okay. This is kind of tough, actually. Let's go to Desmo so I can just like show how this works real quick. Okay, so x squared minus 4x. And then what was it? Plus 8? I think it's just calculus based. Is this a calculus class? Fembox is automatically like, it's just 2. Okay. Oh, it's functions. Okay. Well, okay, so then the other thing you had ax minus 1, right? Where this is the slider. Okay. And then let's change the color in this thing. Okay. So here's a cool thing. Watch what happens. So I can mess with this, with the slope here, until it hits it exactly at 1 point. Oh, that's cool. And he says it's 2. Okay. Yeah, very cool. Yeah. I think, there's 2 conditions here, though, Femvox, right? You also want so watch what happens. As I move the slope here, right? Here it's hitting at like 2 points, and then here's where it hits it exactly at 1. And that's because this blue curve is now tangent to the red curve at a certain point. So, let's get rid of the Desmos here. Okay. So I agree. You need... Oh, I see. And you want it to intersect at only 1 point. Oh, you don't even need... You don't even need, I guess? Thanks, Sam. Okay. So yeah, in order for them to intersect, and we're going to vary this 6 here, I'm going to say that x squared minus 4x plus 8 is equal to mx minus 1, right? But I want this to have just one solution. Yeah? So, I think completing the square is probably the right move here. So this is x squared minus 4x minus mx plus 9 is equal to 0. Yeah. Yeah, and you want one solution, okay? So yeah, a couple ways. You could complete the square, or you could do this with the quadratic formula, right? Because this is the same thing as 1x squared, and then that's going to be minus 4 plus mx. Right? That gets me minus 4 minus mx. And then plus 9. And then here, let me make this like a different color. Right, and so for a quadratic equation, chasm, to have one solution, I need the discriminant to equal 0. So one solution means that b squared minus 4ac is equal to 0. Yes, minus 4. Yeah, you're right. Yeah, okay. Well, the main thing here is, right, this is b squared, so I don't really care. It's going to go away anyways, right? So I get 4 plus m squared minus 4, and then that's times a times c. Okay, cool. So, and then that's equal to 0. So, that's 4 plus m squared is equal to 36. Square root that. 4 plus m is equal to plus or minus 6. So, m equals 4 plus, negative 4 plus or minus 6. So you get m is equal to 2, or m is equal to negative 10. That's cool. Does that work on both cases? Oh, I guess it does. Yeah. Oh, it does do it at 1 point here. Wow, look at that. That's pretty cool. Ah, so you have 2 solutions. I think it can be both too, Kaz. Yeah. Yeah, so there's 2 places that you get 1 solution. So, yeah. You could say y equals negative 10x plus 1, or y equals, was it plus 1? Sorry, minus 1. Or 2x minus 1. Either work. Cool. Nice, that was a good question. I like that. Thank you, Femvox, for showing me the thing. You have a point. And then Winnie, I'll do yours real quick, because I know you've been waiting. You want help with this one, Win? Which one, number 4? A car covers 2/5 of its total distance with V1 speed and 3/5 of its distance with V2, then the average speed is. Oh, wow. Okay. Okay. Let's remember what average speed is. Average speed is distance over time. So let's just call this D, right? So 2/5 D is equal to V1 T1, right? And then 3/5 D is equal to V2 T2. Okay. And then this, right? So this is equal to T1 plus T2. So I'm just going to rearrange this. So I'm going to say, okay, cool. So 2/5 D over V1 equals T1. And then 3/5 D over V2 is equal to T2. And then to get average speed, I need distance, D, divided by T1 plus T2. So that's going to be 2/5 D over V1 plus 3/5 D over V2. Cool thing here is the D's are going to cancel. I'll do yours next, Reiki. Give me a second. Cancel, cancel, cancel. And then I'm going to multiply everything by 5. I'm going to multiply by 5 by 5. Okay? Because now that's going to get me 5 over 2 over V1 plus 3 over V2. And then I'm going to multiply everything by V1, V2. So now I get 5 V1, V2. So this cancels. 2V2 plus 3V1. Nice. Answer is choice 4. Yeah, 4 is correct. Yeah, that's what it is. Oh, it's kind of a doozy. Although, I mean, it helps to know average speed is distance over time. That's frickin' beautiful, man. Yes, even Elon approves. He's starting a new party now, the America Party. Do you guys hear about this? We got a 3rd party coming. Elon. Papa Elon. Oh, man. Okay, Winnie, tell me the next one you want to do. I'm going to do Recce's real quick. You randomly read the news? I read the news every day, or I listen to NPR every day. Like, when I do my dishes or I'm, like, cooking my breakfast, I just tell my whatever Google thing to just play NPR. And I just listen to, like, what's the recent on NPR. Ooh, that would be a good one, Jeff, right? Yeah. I love how, yeah, he isn't an American citizen, but he's starting the American Party. We live in an insane world. All right, Recce, where are you at? Recce. Recce. Where's Sir Rec? No problem. Money. money. Yeah, I think he's a citizen, but he's not a natural born one. Okay. A bouncy ball bounces to 70% of its height when it's dropped on a hard surface. Suppose the ball is dropped from 20 meters. What height will the ball bounce up after the sixth bounce? I think you've done this one, Reki. Reki, you've done this one before. I know you've done this question. I did this one with you. Yeah, okay, so we say like, I'm pretty sure, but here, okay, so height after the nth bounce is equal to the initial height, and then it's equal to 0.7. What's up, my guy? What's up, Gmail user? 0.7 to the end, right? Right, because after the first bounce, it's 70% of what it used to be. The second bounce, it's 70% of 70%. So forth and so forth, right? So after the sixth bounce, okay, so that's h of 6. H of 0 here equals 20. That equals 20. Then that's times 0.7 to the sixth. We meet again. Okay, it was on your final exam. That's okay. Alright, so where's the calculator on this? Yeah, just checking. You good. 2.35 apparently. Cool. And then what's the total distance it travels? Oh, it travels. If it bounces indefinitely? Oh, I see. That's the sum, right? I gotta remember, like, if we... Don't we double it, though? Do we double... I think we double it, right? and then I think we add 20, right? Because I remember this being kind of tricky. Well, because we don't really count... I don't think we count the first one, do we? We don't count h of 0? Yeah. And then... So this is... H0, but then H1 does this. Yeah. So then this is 20 times 0.7, which is, sorry, what's that, 14, right? So this is 14 times 2, and then this is H1. You did? People have drawn me like pictures and stuff before. Okay, and then the sum for an infinite... I'm just going to look it up again because I know it's like S over 1 minus R. You did, Reki. It's great. Love it. Okay. So A R to the K. So A is that front number, so that's gonna be 20, right? And then it's over 1 minus 0.7. And then I think we're multiplying that by 2, right? Because that only gets one of them. And then I'm subtracting 20 from it. Yeah. So it's this times 2, because you have 2 of these geometric things happening every time. But this one, I only had one of the 20s. So, what's that? That's 60? Sorry. 20 divided by 0.3. Oh, it's 200 over 6. Which is 200 over 3. I think it's 20 minus. Oh, okay, that's another way to do it. Thank you, Femvox. Femvox like, yo, bro, you could also just like start at 14. And then just add 20. Yeah. I like Femvox's way better. Yeah, let's just do that. 20 plus 2 times 14 over 0.3. Nice, Aleph Null. I like that. I see a question from Aleph Null. 2 times 14 divided by 0.3 plus 20. Which is 113. I think that's the same as 20 divided by 0.3 times 2 minus 20. Ah, look, it is. Yeah, 113.
Well done.
Nice. Aleph, no, what happened to your question? I saw it recently. I'm pretty sure you got it correct too. Winnie, what other one do you need help with? Was it this one right here? Yeah, where's your question? I don't see it. Did you post it, Shantrix? Okay. Yeah, send it. Is it option 1? Okay, let's see. The velocity versus time graph of a particle moving along a straight time. A straight time. I think mean a straight line. Is shown in the figure. The curve, when plotted, takes the form of a circle. The magnitude of the average acceleration is... Okay. So, average acceleration is equal to change in velocity over change in time. So the change in time is 2 seconds. The change in velocity... I mean, it's from 2 to 0, no? So, yeah, isn't it 2 over 2? Isn't it just 1? I feel like it's just 1. Yeah, minus 1. Yeah, sorry, minus 1, yeah. So, but they said the magnitude of the average acceleration. So, the magnitude is 1. Yeah. Nice. Okay. Yeah, I think one's easy. Oh, let's see. Shantrix got some thinky problems. Okay. Well, I think the first one's easy, no? So you got 5 by 4. The length of the rectangle is increased by 10%. So yeah, wait, isn't just the area? Oh, what is the area? Should just be 22. No? Yeah, okay. Yeah, I'll do yours. Yeah, let me help out Aleph Null then. Because I think this just becomes... if you increase it by 10%, now it's just 5.1. So that becomes... Sorry, 5.5. What am I doing, dude? Do what? There we go. Yes. And that makes sense, right? Because it's a 10% increase in the area as well, because you're only increasing one dimension. Let me see Alef's real quick. Wait for Shantrix to come back. Ooh, angle of small oscillations. 2 strings which lie in a single plane with the vertical are attached to a bob as shown. Okay. You like sports? I like baseball. I played a little bit of it in high school. Not high school, sorry, middle school. I like basketball. I mean, I like all the sports. I was just never very good at them. Okay, I think I need like a force diagram. Because there's an equation for small oscillations. And it's like I over something. I forget what the fuck it is. All right. Oh yeah, baby, me too. What's your favorite baseball team? Okay, so we know this distance is y, right? So this distance here is y. And so then this distance is y plus h. The Blue Jays. Nice. I mean, I grew up really liking the Yankees. My dad was from New York, but then I moved to Houston. I was a big Astros fan for a bit. We did win a couple World Series, albeit we kind of cheated. Oopsies. Okay, then we know this is D1 and this is D2. All right, I can remember like what the equation for small. I literally did this in my class. Wow, no, I don't think I want all that. Don't think I need that, or maybe I do. Maybe we do need to like go into like this type of stuff. I really don't want to. Oh no. What's up, Chantrix? Yeah, okay, cool. There's something with like, it's like the moment of inertia. I taught this, dude. I taught this like last week. Just tired. Yeah. There we go. That's what I want. Where's this MGD thing? What was it? Sorry. Okay, wait a minute. Where is this diagram? I just had it. Yeah, this diagram. That's what I want. Where's that picture? Yeah, 2 pi square root of I over mgd, but where is that from? Because I think if we get the moment of inertia of this thing, we're done. There we go. Sorry, what do they want? They want the angular frequency? Okay, that's this. They do. It's this. Length from the pivot point. The center of percussion. The length is determined by this formula. Yeah, I think this is what we want. Because we're saying we give it a push into the page. So what we're doing is we're pushing it in this way, and then this thing is going to swing like this, right? So I'm tempted to just say it's the square root of mgy, because that's the distance that it's probably oscillating around, and then that's going to be over my squared. So I want to just say the square root of g over y. We need to find the pivot point. Is it not pivoting around here? Is that the problem? Okay, because let me just write some tensions real quick, because I'm sure that these tensions are going to come into play. So I know that T1 cosine theta 1 has to equal T2 cosine theta 2. Right? And then T1 sine theta 1 plus T2 sine theta 2 has to equal to mg. Right? And then I have expressions for cosine. Or, well, I mean, I have expressions for tangent, really. Well, it's kind of annoying. Do the tensions help me find the pivot then, Aleph? I think the distance from the 2 points connection of string with the wall It's the same as tracing two spheres, and the cross section of those is a circle. Huh. Okay. I kind of get that. Yeah, you're saying that, like, from this point of view, for instance, you have, like, in 3D, because the problem is, like, this is a 3D space question, because we talk about pushing this thing into the page. So, three-dimensionally, it has to stay on this, right, it has to stay on, like, a sphere of radius, whatever this is. Which is, yeah, the square root of that. And then this, and then the intersection of those 2 points is a circle, which I could then, I guess, find the radius. That's what I'm doing, find the radius of that circle. Okay. I mean, that's cool. Alright. Geometrically, how do I do that? Come on, Jeff, dude. This is your fucking specialty, man. You love this spherical stuff, don't you? It's your favorite, bro. Yeah, you're getting called out, dog. Why do you teach for free? Because I'm a nonprofit. I don't know. Just doing some nice things out there. Just trying to be nice. Well, if you know D1 and Theta 1, then it's just A tan Theta 1 y plus h divided by d1? Oh, arctan. Correct. Oh, because it's a heart of gold. Thank you, Winnie. Okay, well, alright, I'm going to ChatGPT, because ChatGPT will tell me how it works. Although, Femvox, I do like how you're talking about a quadrilateral connected to the left wall, and two sides short connected to the right wall? Okay, so one thing we can do here, I'm just gonna I'm gonna try to explain this. I mean, I just asked ChatGPT, how do I find the radius of a circle cross section from two spheres? And let's see if it makes sense. This is some weird geometry that is not taught, but is cool to do. So, yeah, we're assuming, right, that this is kind of like, I'm gonna do it in like the 2D space, right? And then we just gotta add a third dimension. So, I don't know, it's like something like that. Something like that, I guess. Yeah, right? Okay, cool. So it says, first, compute the distance between the centers. So, we got to compute the distance between the centers, and that's going to be, let's come up with a different color for that. Let's call it purple. Call it purple. So this right here is like the distance between the two centers. Forget the T1s. I was making this into physics, but I guess it's not really that much physics. Besides the... Right? You think you got the answer? So... Yeah, it makes kind of like a kite. It's kind of cool. Let's see. So in this case, let me see if we agree with the same answer. So d is the square root of their let's call this like the x-axis. So that's d1 plus d2 squared. Their difference in y is just h, right? And then their difference in z is 0. We're gonna assume like whatever z's in the... Yeah, but then I want to figure out. Oh, but the axis of pivot is this. Oh, we don't even need to do this in 3D. Are you right? Do you see what I'm saying? Oh, this is actually not too bad then. Sorry, it's kind of silly. Yeah, just the shortest distance from the red dot to the purple line. Yeah, exactly. Oh, okay. Okay, cool. Yeah, so for my own... Okay. Let me, for my own, like, sanity. Do it in 2 dimensions. Goes off screens and shoots himself. Yeah, because you're right. All we're trying to figure out is now, we're just trying to figure out this. See, ChatGPT kind of helped us out here, dude. Yeah, I'm just trying to figure out this. Which I assume it's tangent to the 2 of them, though. Right? Can we assume it's tangent to 2 of them? Yeah, it will meet at a right angle, right? Which... No, you're right. Oh, fuck. Wait a minute. Oh, no. What's tangent? Tangent means it kind of like lies along it like this. That's like tangent. No, physics is definitely possible. This is technically physics. It's just physics with pendulums. Yeah, I just want to put an XY plane and just work it out. Okay. So the equation of this line then, right? That's going to be let's just call this like 0, 0. Let's just set a coordinate system, right? Let's fuck it, dude. Let's call this like 0, 0. So y is equal to negative h over d1 plus d2, right? Plus y plus h. Or I need to not call this y. Let's call this a plus h. Right? Isn't this like the equation that we have? And then, sorry, there's an x here.
Nice.
That's the equation of the line. So then I have... h over d1 plus d2x. Yes, I'll do yours next, Chantrix. Well, I was doing yours, but then you left. Minus a plus h is equal to 0, right? Okay. And then the distance formula from here to here is this. where this point is just at, this is d1 comma 0, right? So the distance is equal to h over d1 plus d2 times d1. The y is 0. And then we say plus c. So plus negative a plus h. Then all over the square root. This is a fucking mess, dude. Yeah, you can send on Discord or you can send in the Twitch chat. Plus 1 squared. Okay. Is this what you got for your distance, Aleph? No? And is that the radius I gotta deal with? I really don't want to deal with that. This looks ugly.
You gotta get in the hospital.
Painful.
Now. And I just said, just shut up and let me enjoy this pain.
Yeah, it's painful. You used FBD. Free body diagram? Wait, what free body diagram did you use? What? Did you use this stuff? How's a free body diagram gonna help you get that distance? Yes, 1K, it did happen. Equity 1. Sorry, I just used trig. I'm using FBD for everything. It's okay. It's okay, man. I'm used to using FBD for everything. What's up, sup? Good to see you, bro. Okay. I'm kind of curious. I'm gonna throw this bitch in the ChatGPT and see what it says. Because I think, I mean, this is a very messy equation for D. And then I gotta plug that into here for this to get omega. I really don't want to, but could be. Let me pull this one in. Yeah, it is just a mess, which sometimes does happen because of the 2 stars. If there's 2 stars on a question, usually I'm like kind of scared. Oh my god, it's about to be a big pile of shit.
That is one big pile of shit.
It really is. ChatGPT seems to want to deal with the tensions. Because it starts saying the restoring force comes from tensions in the strings. Yeah, I didn't want to get into this. I was thinking... Sorry, where's pendulums? Yeah, because if we have to deal with this is where things start getting really messy. You're okay, dude. Dude, do you want to see what ChatGPT is doing right now, dude? Get the fuck out of here, dude. Oh, does the net restoring force? Like, stop. I don't want to do this. A little algebra gives you this. Okay. Which, you know, this is kind of looking similar to what we got, right? What do we have? Well, I had this. I had G over Y, right? But then the question is like, what is Y? So maybe I'm seeing like some D1 plus D2 in here, you know? Also, we said it was equal to, equal to the square root of G over D. So maybe there's some simplification here. You call like something like big, something small. Yeah. I'm gonna punt on this one, just because it's making me upset. Frog Thick, nice. You did post me a lot of questions. Frog Thick, you dumped like a metric fuck ton. Can you pick like one or two ones in the chat? Just let me know which one or two you want help with. I unfortunately don't have enough time to go through like your entire sheet, but if you pick a couple, I'll do them. Yeah. These. See, you dump these. Shantrix, I will do yours, but yeah. Give me a couple. Give me a couple that you want to go through. One question for each. Okay, thank you for the question, Aleph. Let me think about that more, or I can repost that in our forum thread just to see if someone has some more time on it. If you get the solution for it, please send it to me. I would love to see. I want to know whether we would have to go through this whole like derivation. This is kind of a mess. With restoring forces, I was trying to do forces, but man, yeah, no, I really don't want to do it. Wait 10 minutes, please. Okay, I'll wait 10 minutes. You're gonna have the solution in 10 minutes? How are you gonna have the solution in 10 minutes? Okay. Alright. Area of a square is 100 centimeters squared. When its length is increased by 30, and its width is decreased by 30%, the area of the resulting triangle is less than 100. Determine the percentage by which the area decreased. Oh, that's cool. So instead of like length times width, now you have 1.3 length times 0.7 width. Oh, that's not too bad. So what is that? 0.91 length widths. So decrease by 9%, right? Decrease by 9%, yeah. This one? Don't think that was too bad. Decrease by 30% to 30%. That's actually kind of cool. Increase by X, and its width is decreased by 20. If the area of the resulting triangle is equal to it, determine the value of X. Oh, okay. Well, that's easy, right? So I need 0.8 of 1 over 0.8. So 1.25%. So 25%. Yeah, this is 25%. Because 1.25 times 0.8 will get you your original 100% of your length times width. Wow, I'm sharp.
That's dope.
Cool question, Shantrix. No, I like them. Those are good. It's actually interesting how like increasing, decreasing by like the same percent actually decreases the whole thing.
Well done. Well done.
That's pretty cool. I didn't think about that. I always learn something every day. Okay, Frog Thick. Or Xenos. Xenos is the goat. Taking some physics today. Oh, it's taking a bigger chunk than it's replacing. That's true. Okay. Use the following position versus time graph to answer the following. What is the speed of the object between 0 and 30 minutes? Okay, so speed's always just equal to distance over time, right? Yeah, we're doing a lot of physics today. So between 0 and 30, I don't know, was that 0.75? Or no, sorry, what the hell are these units? Oh, this is 1.5, okay. So it went from 1.5 to 0.75. So here you're going to get, this is equal to 0.75 minus 1.5 all over 30. It's equal to 0.75 over 30. I don't know. 0.025. I want to say that's correct. Oh, yes, and that's also in, like, kilometers per minute. Do they really want it kilometers per hour? They didn't tell me, technically. Yes, that's kilometers per minute. Which, yeah, you need to multiply by 60 minutes in 1 hour to get kilometers per hour. Sure. Ooh, Aleph, you already got an answer for me? What's up? So, yeah, 1.5 kilometers per hour. I want to see what Aleph has for me. Alright, Aleph, let's see what you did. Uh-huh. Okay, so you went and did some stuff. Oh, okay. Oh, this is cool. And then G cosine theta is the amount doing simple harmonic motion. G cosine. Yes, sure. Okay. So you got this. Let's see if that's what. I think that's pretty close to what they got. Alpha null is on fire, dude. Yeah, nice. Look at that. Yeah, you're correct. Do you see this? Yeah, this matches with this. That's very cool. Sauce packs per jiffy. Nice. I like, yeah, this was a cool way to do it. Wow, the geometry here. This is why you can't ever, like, forget your trig, guys. You always gotta know your trig. Mm-hmm. Cool. What class is this for? By the way, like, yeah, what is this? This can't be, this is not high school physics. There's no way this is high school physics. I would venture. You're in 12th grade? Wow, congrats, dude. I wouldn't even do that in 12th grade. I don't even do that in college. That's like too much. All right. Probably JEE advanced. Yeah, probably. Probably. Oh, it's a competition. Or you are... It is JEE advanced. Yeah, bro. This is what I'm always talking about, Femvox. This is the insane exam they have in India because, like, there's way too many people that want to escape poverty. So they just make like the most absolutely ridiculous physics questions for them to try to solve. It's like who out of the billions of people really wants it? Wish I came through that program. I don't. Man, that would have like beaten the fun out of physics for me like pretty quick. I mean, it's good. It's like, yeah, it's like the Olympics basically of like doing physics. But in my mind, you're solving like a lot of like ridiculously difficult stuff that's just difficult for the sake of being difficult. It's cool, but I don't know. I think if we started doing that in the US, we would turn everybody off to physics. No one would want to study physics. Chem is what scares you? Oh, I like chem. Is there a JEE advanced for chemistry? PCM is what they call it. Okay. Let's see this one. When is the object moving the fastest? Oh, this is always curious because you have to. Yeah, it's like, is the velocity the biggest or the speed? I think they're talking about the speed here. So that's just like the magnitude of the slope. So it's like magnitude of slope. Oh, PCM subjects in. I get you. There's JEEP chem maths. Okay, cool. I wonder what the chem is. Moving the fastest. Where does it have the most slope? I think it's section E. I think it's got the highest slope. Just look at the slope. See which one's the biggest. This one has the biggest slope. Moving in a positive direction. So that's where the slope is positive. That's A and E. Negative direction would be C. And then not moving, that's where the slope is flat. That's going to be B and D. And then average velocity between 0 and 20. That's 24 divided by 20. So it's just the change in the distance, which is 24, divided by the change in time, which is 20 seconds. Dun, dun. But what's average speed? Average speed is the same thing as average velocity. It's just it doesn't have a positive or a minus sign on it. Also, if the thing is moving up and down, yeah, then we gotta fuck with things. Yeah, I take that back. Because then I have to like calculate. I have to calculate the change in the distance, not the change in position. Yeah, average velocity is change in position. So it's displacement, and then average speed is, yeah, distance. Yeah. But yeah, that's average velocity. Yo, Aleph, show me what like an example chem JEE question is. I'm curious. This? What is this? 6, 7, 8, 9? Average speed. So that's going to be 9 meters over 0.8 seconds. Cool. Instantaneous at 60. Oh. I guess what you got to do is... You got to like take like a point before and a point... Well, this is kind of actually really hard to do. You have to like kind of guesstimate what this is, what this slope is. What's up, Titan Lord? It is kind of a problem. Okay, where's Frog Thick? Which ones did you want me to do? I did like one kind of each one. I'm also getting tired. Let me see. Guitar Ninja sent me something. Ooh. What up, Guitar Ninja? Oh, you mean from each worksheet? Oh. Okay, well, one sec. Not from each page. Okay. Okay, one second. Let me do this, and then I'll do the other two, and then, yeah. Then I have to actually go tutor somebody else for money. As much as I love helping you guys for free. I do have to pay rent, eventually. Mm-hmm. The height H. Oh, you're okay. That's alright, Aleph. I was just curious if you had it on you. That's fine. Yeah. So basically, I need MGH here to equal MG times 0.4 plus 1/2 MV squared. Right? What's up, Titan? By conservation of energy, right? Okay, so... And I think all the M's are going to cancel, right? I think I don't need these. Go away. Okay, so GH is equal to G times 0.4 plus 1/2 times 9. So H is equal to G times 0.4 plus 9/2 all over G. Did we get an answer that's reasonable? Get 0.86. Answer choice C.
My man.
Alright, nice, dude. Have a good night there, Aleph. Yeah, glad you came by. Yeah, come by. Ask questions anytime. I think they're fun. Good luck with escaping the competition of physics through JEE. I don't envy you. It looks pretty brutal. Okay, was this one was this 0.86? Guitar Ninja? Yeah, hard but interesting, exactly, yeah. It was using like restoring forces, which was pretty cool. Okay, I think that one's 0.86. Let me see a couple. All right, Xenos. I'm gonna pick this one. Velocity versus time graph. Where is the velocity of the object the greatest? Oh, well, where the velocity is the greatest. So that's between 10 and 20 seconds. Your teacher gives you no fucking room to, like, write things. What? Where are you supposed to write the answer? Jesus Christ. You learned this before? Nice.
Perfect. Good job.
Okay. A is like between 10 and 20 seconds. Yeah, well, speed versus distance is kind of the same. It just doesn't have a direction. When is the acceleration the great? So this is cool. The greatest, they mean the most positive. So not the most slope, the highest or the most positive slope. So yeah, that's between 10 and 20. But 0 and 10. Good. Does mean gradient. Correct. Where's the acceleration? 0? Oh, that's also between 10 and 20. But also between 30 and 40. Okay. When is the object slowing down? So the object is slowing down when the velocity is if it's positive and decreasing, or if it's negative and increasing. So positive and decreasing, that's from 20 to 30 or 40 to 50. Sup says why. So, just a quick little explanation. Let's say you had an object going at 20 meters per second, and then you had it going at 10, or let's say like 15 meters per second. And then the time in between this was equal to, I don't know, like 5 seconds, right? So, in this case, the speed is decreasing, right? Because you have 20 and 15. You know, speed, you're looking at the magnitude. You don't look at like the positive or negative of it, okay? But then velocity also decreasing, because you have final minus initial, which is equal to -5. And then so that means acceleration is negative, because it's change in velocity over change in time. That'd be -1 meters per second squared. Now let's say you have an object going 20 meters per second here, and then later it's going at 15 meters per second, but it's going to the left. Okay, in this case, speed is still decreasing, right? You're going from 20 to 15. So that's the same. However, velocity is increasing, because you're going from -20 to -15. So if you do final minus initial, -15 minus -20, now you get +5 meters per second. Okay. And so acceleration is positive. And that equals +5 over 5, which is equal to +1 meters per second squared. So that's where you have to be tricky. Speed only refers to like the size of the number in front. Oh, why is acceleration the gradient? Well, it's the derivative of velocity, which, yes, in 3 dimensions is the gradient, but you usually only have to do things in like 1 dimension, man. So acceleration is equal to dv dt, okay, which without using calculus is change in velocity over change in time. This can also be written as grad v. This is a derivative in like all 3 directions is what it is. And this is also called gradient. This is like a one-dimensional gradient. All right, good to see you, Titan.
Good job.
Is calculus in grade 12? No, dude, I love calculus. So calculus is an awesome math class because things make sense. Like, the reason why you're learning things makes sense. Like, there's a story. When you're in, like, trig, like pre-calc, or, like, even, like, geometry, I don't know, it feels like a bunch of, like, random grab bag of topics. You know, you're like, oh, we're learning about sine and cosine. Okay, but now we're going to learn about polar coordinates, and, like, now we're going to learn about, I don't know, fuck all, something else. And it's all pretty random, right? And it's because you're learning all these little tools that you need in order to do calculus. And when you do calculus, there's a path. Like, you learn about limits. Limits allows you to learn about derivatives. Derivatives allows you to learn about optimization. And from that, you can then do, like, I don't know, all sorts of other cool shit, like related rates. And then you learn, oh, okay, so derivatives was rate of change, but now we're going to go into integrals, which is like the anti-derivative. It's like the opposite of a derivative. You're finding the area under a curve. And now that gets into, you know, volumes of revolution, and you can do sequences, series. Everything seems to build upon itself, and you can kind of see the path of, like, why you're learning things. Versus other math classes, I know. You look at it, no, and you're like, why are we learning this, bro? Like, when am I ever going to use this? In calculus, it's a lot easier to see directly ahead, like, why you're going to use it. And you're like, oh, okay, makes sense. Integral is the opposite of differentiation, yes. It's the inverse, I guess. It's the anti-derivative is what they call it. But it's very cool. Derivatives deal with, like, how much the slope of a curve is, and then integrals deal with like the area under the curve. And those are like opposite things. You do it in physics, right? You know, the derivative of a velocity graph, right? So dv dt, that's equal to the acceleration. But if I figure out the area under a velocity graph, that's equal to the change in position or the displacement. Yeah. So this is where like derivatives and integrals are kind of like backwards to each other. Right? Remember? So v equals dx dt, a equals dv dt. But then let's say this is x, okay? If you take the area of a velocity graph, you get position. If you take the derivative of position, you get velocity. And then it's the same thing here. If you take the area underneath an acceleration graph, you get the change in velocity. And then if you take the derivative of velocity, you end up getting the acceleration. So this is why they're all kind of related to each other. Yeah, they're really cool. I mean, and this is calculus. Calculus does this. Calculus shows you why these things are all related. And I think that's why it's cool. You learn a bunch of like random shit in math, and then you start realizing that it makes sense for the real world. Okay. Shit. It's almost 5:30. I gotta go teach another student, so I gotta wrap the stream up, but I hope this is useful for you guys so far. Alright. Thank you everyone for coming to office hours today. Appreciate all the follows. Appreciate all the questions. Appreciate y'all hanging around. Our next stream will be tomorrow. So if you want to come by, ask more questions, that's at 4 o'clock Pacific, 5 o'clock Mountain, 6 Central, 7 Eastern. There's a calendar if you want. There's the link to the calendar. If you click on this, you can find out when we are streaming, as well as when all of our other awesome friends in math and science are streaming. So, oh, awesome. So tomorrow morning, starting at 8 a.m., if you want to like see calculus, Zach on E to the 2i pi is doing an integrals marathon. So he's going to do 100 integrals on Twitch. That's crazy. So yeah, come on by and go see Zach. If you want to see like some hardcore calculus, like Zach's going to be doing some for a while tomorrow morning. He also has a math stream on Wednesday. Penn Center's doing machine learning on Friday. And then these are our office hour streams, which you're more than welcome to come by, learn stuff, ask questions. We'll help you out. Okay. Let's go raid somebody on Twitch. So yeah, if you're watching us on Twitch, we're going to take you to another one of our friends who does like math or science stuff. It's good to just combat the brain rot, you know? As much as I love watching Nick Merckx like just spaz out at a gym, it's kind of nice to do some math or science on Twitch. Nice. Looks like Obi is doing some stuff. Yes, let's do it. All right, we're going to go raid Obi. Obi's a great guy. We love Obi. It looks like he's 3 hours in. Okay. Enjoy the beginning of your week. We'll see you tomorrow. Peace.